The next thing we're going to have a look at in this video is something called theoretical probability. So theoretical probability is all about assigning a number to the likelihood of an event occurring. So in this case, consider the notation up here. There we go. So we've got P of E equals number of outcomes corresponding to E divided by number of outcomes in the sample space. So P of E stands for probability of event E equals. Now, what we need to do is ask ourselves, firstly, what is an event? So an event occurs when we attain an outcome of a particular property or feature. So an event itself is the action of, let's say, a phenomena occurring. So say if you're flipping a coin, you could say the coin flip is an event. Now the second part is sample space. What is sample space? Well, a sample space of an experiment is the set of possible outcomes. So consider, for example, I'll write this in green. Consider the rolling of a cube die, we could say that that is 1, 2, 3, 4, 5, 6. So represented in our list using set notation, the sample space is simply all of the outcomes, so the number of the outcomes, so n of outcomes, or O, equals 6. So there are 6 different outcomes. Now going back, we said P of E, so probability of event E equals the number of outcomes corresponding to the event divided by the number of outcomes in the sample space. So looking at a die example again, consider the rolling of a die. What is the likelihood of rolling a 3? So we could rewrite this as probability of rolling a 3 equals number of outcomes corresponding to E. So let's write O equals 1, 2, 3, 4, 5, 6. So how many outcomes yield a 3? Well, it's only this one here. So 1 divided by number of outcomes in sample space. So how many numbers or how many members are in set O? N of O equals 6. So it should be 1 over 6. Now getting my calculator out. Where are we? We're going to have 1 divided by 6 is 0.166 or 1/6 remainder. And converting that into a percentage, that would be 16.7%. So the probability of rolling a 3 on a cube die would be either 1 in 6 or 16.7%. Now, let's go down to another example. How about rolling a number above 4? So, probability of rolling above 4 would be number of outcomes corresponding to E. So let's go back, and I'm gonna grab all of this, move it over here. And we're going to ask ourselves, which numbers correspond to this event? So if we rolled a 1, 2, 3, or 4, then not above the value of 4. So we want to know the outcomes of rolling above 4. Well, that could be 5 or it could be 6. So what is the number of outcomes corresponding to this event? Well, it is 2. And number of outcomes in the sample space, well, how many numbers are in here? Well, it is n of set 0 or set O equals 6, so 2 in 6. Now, simplifying that, that becomes 1 over 3. And I don't need my calculator to do that. I simply know it's 66.67%. No, it's not. It's 33.3%. Perhaps I should have used my calculator. So going back, what is the likelihood of rolling a number above 4? Well, the likelihood is the probability of rolling above 4 equals 2 in 6, or 1 in 3, or 33.3%. Not too bad. So in conclusion today, guys, what we learned was, firstly, how to represent our data using lists. So again, this was simply using set theory notation. So stuff we did in learning intention 2. Nothing too difficult there. And then we learned how to represent data using grids. So this would be two-dimensional data. Then we looked at representing our data in tree diagrams, so two-dimensional data or multi-step experiment data. Trees were great for multi-step experiment data. Then finally, we looked at theoretical probability, so how we can assign a fraction or a percentage to explain numerically the likelihood of an event occurring. So it wasn't too much information that we had to process today, but again, what we're doing slowly is building up our toolbox of information, or toolbox of methods of explaining theoretical or probability data. So the intention over the next few weeks is we'll keep adding these tools to our toolbox, and we'll continue to use them or practice them so that we will be in a good position when we're doing, say for example, statistics. So if you had any problems with this subject matter, let me know, and I can do some examples perhaps, or we can talk about it in a little bit more detail.